Hello everyone, I am Gyan and you are learning computer science with Python for class 11th. In this video, we are going to learn the concept of compiler and interpreter. The concept of compiler and interpreter. INTERPRETER. Concept of compiler and interpreter. See, whenever you write a code, you write in a programming language. A programming language like Java, like Python, C, or C++. But your CPU only understands few basic instructions in machine language. If I talk about your CPU, then your CPU understands few instructions written in the machine language. Machine language means binary language. So your CPU has already fed instructions in binary language, and your CPU only understands those languages which are written in binary, okay, inside the CPU. So how you write your code? You write your code in Java, Python, C, and what machine understand? The machine understand binary language. Your CPU understand binary language. The instructions fed in the CPU in the binary, your CPU only understand those instructions. So what CPU understand? CPU understand machine language or binary language. So what we want is, we want a translator which converts a code written in Java, Python, C to a code written in the machine language. We need a translator. In the very same way, if you want to talk to a Chinese, you need a translator who can translate your language to Chinese. In the same way, here you need a translator who can translate your Java, Python, C or C++ code to the machine language. Now, the first question is, can we directly write in machine language? We directly write codes in machine language? Can we directly write codes in machine language? The answer is yes, we can write, but that will be very difficult, even more difficult than the human perception. We cannot understand the machine language. We cannot think in the machine language. We, the human beings, are very used to of writing a language or using a language like English. So we want a programming language which seems like English. So if you look carefully, the Java, Python, C++ are such programming languages which looks like English. We cannot code in binary like this. We cannot code like this. We cannot remember what to write. But these languages can be remembered by a normal human being. That's why we as the human being write the code in these programming languages like Java, Python, C, C++ called high level language. High level language. And something called translator, which translates our high level language to the machine language, which can be understood by the CPU. Now, let's formally start the discussion of compiler and interpreter. So, if you talk about the basic flow of compilation, basic flow, the basic flow of compilation is, first you have the program written in C, C++ or any high level language. I am writing HLL for the high level language. That will be converted to the binary form. That will be converted to the binary form, and that will be converted by the use of translator. So a translator converts a program written in high level language to the binary form, and finally this binary form gets executed on the CPU. Execution of the program on the CPU. Okay, this is called the basic flow of compilation. Now you have two types of translators that we are going to study. We have two types of translator. The first one is called compiler, and the second one is called the interpreter. Interpreter. So first let's talk about these two types of translation one by one in very brief. Then I will elaborate the explanation of these two. Let's first see how compiler works. How compiler works. First, I want to say you that in this course you are going to use Python, but the Python never use a compiler. The Python always uses interpreter, not compiler. So to learn about the compiler, you need to focus on some other language called C or C++. Okay? C and C++ uses the compiler. Now, you have the program written in the C or C++. You have a C++ code stored as first.cpp. Okay? That code you pass to the CPP compiler. That compiler produce a exe file, means executable file, and that executable file can be saved on the disk. Okay, what this compiler does, compiler accepts all the C++ file all together and converts all the C++ file as a whole into the exe file at once. Okay, means the compiler does not convert the various instructions of C++ files one by one. It converts all the instructions written in the C++ file at once into the exe file, and that is called the compiler. This exe file can be saved on the disk. You can save this exe file on the disk. Okay, you can save this on the disk, and further from this disk you can send it to the CPU for the execution. So again, if you want to execute this exe file, you do not need to again create the exe file from the C++ code, because you already have the exe file. And without having the C++ code, if you have the exe file, you can execute it. You do not need the first.cpp file. You do not need the compiler again. Once exe file has been created, you can reuse it to execute. And this is the beauty of compiler. Okay, now coming to the interpreter. Interpreter is something different. Interpreter is something different. What interpreter does is, interpreter takes a Python code. Yes, Python uses interpreter. So here I am taking an example of Python. You have the Python code, first.py. What interpreter does is, interpreter takes line by line of Python code, line by line of the Python code, and convert line by line of the Python code to the machine language and pass it to the CPU. Means the interpreter takes line by line of the Python code, converts every line one by one to the machine instruction, and send those machine instructions to the CPU. The interpreter never saves any intermediate result like compiler. As you have seen, the compiler saves an intermediate file called exe, but interpreter never do this. Interpreter never save anything on the disk. Okay, so the machine instruction, I am writing me for the machine instruction. Interpreter generates machine instructions one by one for all the instructions in Python. So that's what the interpreter is. Now let's dive little deep into the process of compilation. A compiler is not just a one-step process. That means if you pass your C++ file to the compiler, then the compiler creates the exe file. But this process of compilation is not as simple as you are looking at it. The process of compilation is actually made up of more than one stages, more than one sub-stages. So let's see the compilation process in more depth. The compilation process. The compilation process. So there are more than one sub-steps involved in the process of compilation. The first step is called pre-processing. The first step is called pre-processing. Now the question is, what do you mean by pre-processing? Whenever you write a C++ code or a Python code, you always include something called comment in the code. The comment is not meant for the compiler. Compiler should ignore the comment from your C++ code. Okay, and then compiler should create a fresh file without the comments. Now the question is, why you include the comment? you include the comment for your reference. See, if you write a few lines of code, then after some time, you may forget the logic of that code. In that case, it will be hard to understand your own written code. Or if someone else is reading your code, then that person may have a hard time while understanding your code. In such situation, comment helps the reader of the code. So the comments in the code are for the readers of the code. That means if you have implemented a logic in the code and you also have written that logic in English using the comment, then that comment will help you later understanding that code. And this is the use of comment. The compiler always ignores the comment. And in the stage of pre-processing, actually the compiler deletes all the comments in your code. So the comments are for the reader of the code, not for the compiler. The second thing is that you may include some module written by others. That means suppose that in your code you are using a square root of your number. So the calculation of a square root has been taken from some other module, say the math module. Okay, so you have taken the calculation of the square root from the math module. That's why first you need to include the math module in your code in order to use the square root. So what the preprocessor does, the preprocessor attaches all the modules which you have included in your code. So there are two works of preprocessor. The first one is removes the comments, and the second work is add the imported components. Adds the imported components in the code. Components in the code. So this is the work of preprocessor. So after the pre-processing stage is done, all the comments will be removed and all the included module will be attached to the C++ code. The second stage of compilation is called compilation phase. Yes, compilation phase. This is the actual compilation. Actually, the stage of compilation has been again divided into two stages. The first one is called the analysis phase. Analysis phase, or also called the front end page. The front end page, not page, it's phase. So the analysis phase and the front end phase. What happens in this phase is compiler reads your code and collect all the words, all the different symbols used in your code. That means if your code has, suppose that this is your C++ code, if your code has, if a is equal to 2, cout, don't worry about the meaning of the code, this is just a code. Okay, think it as a code. Cout apple. Okay, so what compiler does here is the compiler picks all the words, all the different words used in this code. If is a word, this opening bracket is a word, a is a word, these two equal signs together are a word. Why these two equal signs together are a word, I will explain it later in the later videos of this session. Okay, 2 is a word, cout is another word, this one is a word, this quote is a word, apple is a word. No, in fact, apple inside the code, apple inside the code is one word. Apple inside the code is one word. Then this closing bracket is also a word, and this closing bracket, this closing small bracket is also a word we forgot to include, and this opening curly bracket is also another word. So we have these many words in the C++. How I am picking the word, you will come to know later in this session. Okay. So in the analysis phase, the compiler picks all the words used in the C++ code and create something called symbol table, because all these words are the symbols using which you have created your code. So compiler picks all the words from your C++ code and put them into something called symbol table. And compiler uses symbol table later for the other purpose. I am not going to explain where the compiler is going to use the symbol table, because the compiler design itself is a complete huge course of BTech. So I cannot explain you everything right now. But you can remember that all the words of C++ code has been taken by the compiler and put into a table called the symbol table. See, the words are of two types. Okay, the words picked by the compiler are of two types. One is the word which has a special meaning for the compiler, and other are the words which you have created. Okay, if is a word which has a special meaning for the compiler, and a is the word created by you, and the word which has a special meaning for the compiler and not created by the programmer are called keywords. Cout is the keyword. Okay, if is the keyword. Few words here are the operators, like this one is the operator. This opening small bracket is an operator. This one is an operator. This double equal sign is an operator. This one is also an operator. So in the analysis phase, compiler identifies all individual units in the source code, identifies all individual units, and you can say that you have various types of individual units. Some are variables, some are keywords, some are operators, and etc. So the compiler in the compilation phase identifies all the individual units and collect them in the symbol table. Collect them in the symbol table. Symbol table is useful for determining memory requirements. For determining memory requirements. Determining memory requirements means while creating the symbol table, the compiler comes to know that how many variables you have created and how much memory you actually require. So this is the one use of the symbol table, to determine the memory requirements. And there are few other uses of the symbol table also exist. After the analysis phase, you have something called synthesis phase. SYNTHESIS, synthesis phase. This is also called the back-end phase. Synthesis phase is also called the back-end phase. During the back-end phase, the compiler again go through the code and create something called a syntax tree. Okay, the compiler again go through the code and create something called syntax tree. Let's see the example of syntax tree. Suppose that you have an expression used in the code is a is equal to b plus 2. So here you are going to create a syntax tree. How the syntax tree will look like? You have equals operator, then you have a, then you have plus, then you have b, and then you have 2. So don't worry about what this synthesis phase does and what is the syntax tree. Right now, since you do not know anything about the programming, that's how it will hard for you to understand what the syntax tree is. So syntax tree helps the compiler to analyze the syntax of the code, create syntax tree, and analyze the syntax of the source code. And if during these two stages, means the stages of compilation, if the compiler finds any error, then the compiler generates the error at the compile time. Okay, so if you are getting a compile time error, then most probably you are getting the error at either at the analysis phase or at the synthesis phase. That's why you are getting the error at the compile time. But since you are going to learn Python as the first language of your life, so you have never used compiler in your life and you are going to use just interpreter. So right now, practically you don't know how the compiler works because you have never used it. And you are going to use interpreter with Python, not compiler. So in these two stages, the compiler checks for syntax and semantic errors. Syntax and semantic errors. So you may ask, what do you mean by syntax error? What do you mean by semantic error? The syntax error means error in the grammar. Okay, suppose that you are writing something in the English and you are making mistake in grammar. So that error will be the syntax error. But the semantic error means you are correct in grammar, but you are meaningless. That is the semantic error. So error in the grammar is called syntax error, and error in the meaning is called semantic error. What I mean here is that just like natural languages like English, the programming languages also has a grammar. Okay, the programming languages also follow a rule, and that set of rules are the grammar for the programming languages. If you do mistake in the terms of grammar, then that is called the syntax error. But if you do mistake in the terms of meaning, then that is called the semantic error. If I say Mohan are a good boy, this is the syntax error. I am mistaking the grammar. Mohan are the good boy. This is the grammatical mistake. Okay, but if I write here Mohan is a good girl, this is the semantic error. This statement is meaningless because Mohan is a boy's name. And the semantic depends on situation. Maybe a girl exists whose name is Mohan, I don't know. But normally in my situation, a girl named Mohan is a meaningless, is something meaningless. And that is the semantic error for me. So the semantic error changes language to language. But syntax errors are almost same in all the languages. Here, if I am talking about language, then I am talking about the programming language. I am talking about the C, C++, Java, Python. I am not talking about the natural language. After the synthesis phase, you have something called assembly phase. After the synthesis phase, you have something called assembly phase. See, the pre-processing phase creates intermediate code. Okay, the pre-processing phase creates intermediate code. The compilation phase accepts the intermediate code generated by the pre-processing and create an assembly level instruction. So create an assembly level instruction. Then you pass this assembly level instruction to the assembly phase. This assembly phase receives the assembly level instruction and convert into a kind of machine code called the object code. But that object code created by the assembly phase is not the complete code. So what assembly phase does is converts assembly level instruction into machine level instruction, also called object code. Okay, then you pass object code to the linking phase. Linking phase. See, I am doing a mistake here. After compilation, you have a very separate assembly phase. Then you have linking phase. At the linking phase, binaries of all the extra libraries will be added to the object code. So binaries of all the extra libraries libraries will be added to the object code. Okay. After the linking phase, your full-fledged program has been created. Now you are all set to load it. So the final stage of the compilation process is called loader. Loader, loader. So the next stage is loader. The loader actually loads the created full-fledged program into the memory. And can you say me what type of file created by the linking phase? That is the executable file. The exe file, that means executable file, will be created by the linking phase. Now what loader does? The loader loads the exe file in the memory for execution. Loads the exe file in the memory for execution. See, as we already have seen, the compiler works on whole program together to create the exe file, and that's what the compiler is. So if there is an error in a single line of code, then the compiler will not create the exe file for it. Means if you have 10,000 lines of codes and you have an error in one line, you will not be able to create the exe file for the whole 10,000 lines of codes. And actually, you do not need any source code to execute that exe file on some other computer. This is the benefit of the compiler. You have the source code, you have the source code, you are passing the source code to the analysis phase, you are passing the source code to the analysis phase, then the output of analysis phase is going to the synthesis phase. The whole together is called compilation phase. Okay, then you pass it to the assembly. After that, the assembly creates the object code out of it. And if you remember, the compilation creates intermediate code out of it. After the object code, you have something called linker, and linker links all the extra libraries in your object code. Library 1, and these libraries are in the binary. So all the binaries of various libraries in your object code. So all the libraries will be linked to your object code by the linker. And then the loader will load the program into the memory. Okay, so this is how the compilation works. Working of compiler. After the compilation, you have interpreter. Now let's see how interpreter works. Interpreter. The interpreter converts your code line by line into the machine code and never creates any intermediate file like executable file. Okay, so if you have line number 1 in your code, and this is the Python code. Okay, Python uses interpreter. Line number 1, line number 2, dot 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 dot, line number n. Then what interpreter does? It takes a line, interpreter, it takes a line, convert it to the binary. Suppose that this is the binary of line number 1. Then it takes another line and convert this one to the binary. So this is how you keep on converting all the lines into binary. And you never save these binaries into one file like exe. It is not going to save on the disk. So one thing is that suppose that you got an error into line number 1000, then what will happen here is your line number 1 to 999 will be executed fine before you get the error at the line number 1000. and the first 999 lines will be executed fine. If you remember, in the case of compiler, if you have an error in any line of code, then the whole code will not be compiled to create an exe file. But here in this case, even if you have an error at the line number 1000, then also you can execute all the previous 999 lines. So the interpreter works on the code step by step, line by line, and only when the interpreter finishes the execution of line number 1, then only the interpreter moves to the line number 2. Okay, so this is the interpreter. I am not writing the text, but hopefully you got my points. Now let's see the difference between compiler and interpreter. Difference between compiler and interpreter. What is the difference between compiler and interpreter? The first difference. Let me write here for compiler here in this column and write for the interpreter in this column. The first difference about input. Compiler takes the entire program as the input. Takes entire program as the input. What interpreter does? Takes single line of code as the input. Takes single line of code as input. Now what about output? The compiler generates intermediate object code from the whole program. Generates intermediate object code. That means the exe file. Intermediate object code from the whole program. From the whole program. Okay. And what about the output of interpreter? It does not generate any intermediate code. Does not generate any intermediate code. Any intermediate code. Okay. Now what about errors? I'm not going to write about errors. Okay. I'm just going to dictate you and you can write my words. So do you remember what compiler does if it gets error in any line of code? First, the compiler displays the list of errors of entire program in every line with the line number. Okay, because the compiler goes through all the lines of code and wherever it finds the error, it generates the error report for all the lines in the code. But what about the interpreter? Interpreter keeps on executing all the lines of codes which does not have any error. But as soon as the interpreter finds an error at any line of code, the interpreter stops the execution. And interpreter just reports that error at that line of code. It does not report the error for future lines of codes. Okay, suppose that if you have an error at the line number 7, line number 13 and line number 20, then the interpreter will only generate an error at the line number 7. Once you correct the error at the line number 7, then only the interpreter will go to the line number 13 and generate an error for the line number 13. So this is how the interpreter works. The compiler generates all the errors present in the code, but the interpreter generates the first error present in the code. There is one more criteria called always required. Always, ALWAYS, always required. What do you mean by always required? That means if we have compiled a source code of C++, we got the exe file, then to execute that exe file once again, we do not need compiler. We just need the loader. Loader will load the exe file to execute. We do not need the compiler again to convert our source code into the exe file because we already have the exe file. Okay, so compiler is required only once to convert the source code into the exe file. Now, talking about the interpreter. The interpreter translates one instruction at a time and directly send it for the execution in the memory. The interpreter never saves the intermediate code. That's why whenever you need to execute a source code which uses the interpreter, you always need the interpreter because you do not have any intermediate code saved on the disk. So whenever you have to execute the Python code, you always need the Python interpreter. But whenever you need to execute the C++ code, you need the compiler only once just to create the exe file, and then after you don't need the compiler. But in the case of Python, you always need the interpreter because you don't have the intermediate code. Okay, so interpreter is always required, compiler is not always required. So no and yes. Now, if you talk about the workload, since after compilation, the compiler is not required, therefore there is less workload on the compiler. Okay, so less workload. But since the interpreter is always required to execute a Python code, therefore the interpreter has more workload. More workload. So that's all about the compiler and interpreter. Hope you got the concept. See you in the next video.